Okay, so what I'm going to ask you to do is I'm going to ask you to sketch a triangle. Call it ABC. Angle A is going to be 27 degrees. Side A is going to be 25 centimeters. And side B is going to be 30 centimeters. And so what I've done here is I've started the sketch. Okay, I measured it to scale. I've used a protractor to measure the 27 degrees. I've measured the 30 centimeter side. I don't know how long my base is going to be because I still have to put in my 25 centimeter side A. Here's angle A, so side A is going to be over here somewhere. So logically I may pick up my ruler and trace over here somewhere so that I can get to 25 centimeters for this side and draw my arm. And then there would be side A, which is 25 centimeters. Now the problem with this is that there could be other people in the class that would say, well, I would draw my side here, okay, where I could sketch a 25 centimeter line, okay, not a great triangle, but I could draw my side here. My ruler's off by a little bit, but maybe this is 25 centimeters. And so you could be perplexed because there's two different triangles that could be drawn with that given information. Okay, we have the one small triangle that would look like this, or we have the one large triangle that would look like this. And you can see, so angle A is here, angle A is here. This is side B, this is side A, this is side B, this is side A. So, what's the problem? Well, the problem is that, of course, this has an obtuse angle, this has all acute angles, two different triangles, but the same given information. Okay? So what I'm going to show you is this. This is the next section, and it's called the ambiguous case. The ambiguous case, ambiguous means that it has a double meaning. So when we're given two sides and an opposite angle, so SSA, side-side angle, when they are given, how do you know if you're dealing with the ambiguous case? All right, so I've started my triangle here. I cut out some string patterns to show us how side A would react to you drawing a triangle. If I just gave you two sides and an angle, how are you going to tell whether you're going to have the ambiguous case, where some of you might sketch a triangle like this, some might sketch a triangle like this, and neither of you are wrong, but you're going to have totally different answers? Well, it's all based on these four pieces of string. Okay? These four pieces of string represent side A. The first case, which is the easiest case, is this long string. This long string I cut to size so that it is actually longer than side B. Okay? So the only possible triangle that I could draw would be this one. I would have to extend my base over, and I would have this large acute triangle. Because notice, as I swing this around, I couldn't create that other obtuse angle triangle because this arm is too long. It extends past B. So that's the easy case. There's no ambiguous case if side A is larger than side B or equal to side B. Large string. Okay? The next simple case is this very short string. When we have a short string representing side A, how many triangles can be drawn if side A is this long? Well, notice how side A, if I swing it around, never touches the base. Side A is too small to create a triangle. So, one condition of the ambiguous case is no triangles can be drawn. With that given angle, and this side length for B, this side length for A, no triangle is possible. You can't draw it. Not possible. Condition 2, you have this side length. I cut that length for a reason. If A is that exact length, only one triangle can be drawn. If I swing this around, you'll notice that it represents the perpendicular height of this triangle. It goes from the top to the bottom. If I swing it further, I can't create that obtuse triangle that we had in the first example. The only triangle I can create is this right triangle. So in other words, if side A represents the height of this triangle, there's only one single triangle that I can draw. Okay? And lastly, I have this height, or this length. That is length A, or side A. In this particular case, this is truly ambiguous. It represents the first situation that I just showed you, where I could draw a triangle that looks like this, reaches from the top to the bottom at exactly that length. And if I swing it around, I would have an obtuse triangle as well. So there's two different triangles that I can draw with this length of string. Okay? All right, quickly, 4 situations. Side A is longer than side B. There's only one possible triangle that can be drawn, and that is that big one. Next case, side A is too small to create any triangles. Never touches the base. It's too short. Side A is too short, doesn't work. Third case, side A is exactly the same length as the height of the triangle. Would only intersect the base right here at the perpendicular height. It doesn't intersect anywhere else if I swing that around. Okay, only intersects at the perpendicular height. And then lastly, we have a string, or a side A, that is longer than the height. Whoops, stuck to my finger. It's longer than the height, and it creates an obtuse triangle, or it creates this acute triangle. So what is this all based on? How can you tell whether you have the ambiguous case or not? Well, you have to be given two sides and an angle, like what's given here. Here are my sides, the strings, right? I have side B already given, it's this long. I have the angle it's given, it's creating the two sides. And then I have my swinging arm. I call it a swinging arm because when I attach it up here and I swing it along, where do I hit the baseline? I hit it here and I hit it there if I swing it around. This length of string creates two triangles, which is the ambiguous case. This length of string on my swinging arm never touches the base, therefore it doesn't create any triangles. How do you know? It's all based on this one string. It's all based on the height of this triangle. Can you tell me the formula for the height of this triangle if it is in fact perpendicular? Well, we'll find out more tomorrow.